So today we will try to again revise it, the content whatever we have seen previous. So as I told you, very important chapter is there, known as the surface tension and interfacial phenomena, right? So from physical pharmacy they are going to ask you at least 7 to 8 questions, and that will be asked from few important chapters like micromatrix, rheology, chemical kinetics, colloid, surface tension, interfacial phenomena, phase rule, etc., etc., state of matter, etc., etc. So out of that also rheology is very important, we have already finished that. Then micromatrix is important, we have already finished that. Then colloid chapter is also important, we have also finished that. So from physical pharmacy, surface tension, okay. So surface tension again very important chapter, and you can expect at least 2 3 questions every year from this chapter. So surface tension and interfacial phenomena. So first of all, you should understand what do you mean by surface and what do you mean by interface. So surface is nothing but the a thin, okay, it is a thin limit of contact. So surface occurs in between the solid and gaseous state. It occurs between the liquid or gas state. So surface, there is a thin boundary over here. Sorry, there is a thin layer of contact known as a surface. Surface occurs between the solid and gas, or solid and liquid and gas, but between two immiscible liquids. If you try to mix two immiscible liquids in a beaker, so for example like oil and water, so there existed boundary between two different phases. Now that boundary is known as the interface. Okay, so you might have clear got what is meant by surface and what is meant by interface. Okay, so actually these things I should not explain to you because already you have done with this in a college. So boundary is between solid and, okay, boundary is between solid, boundary is between solid and liquid is known as an interface. So boundary between solid and air, sorry, solid and liquid, and or liquid is known as an interface. Boundary between solid and gas is known as a surface. There is no interface between two gases because they are completely miscible. ना, अगर दो गैस मिक्स किए, there is no boundary between them. अगर दो miscible liquids, if two miscible liquids they are mixed, miscible liquids, in that also you don't have any boundary because they are completely miscible, right? But immiscible liquids, in case of immiscible liquid, so you have interface, right? So surface and interface, right? So what do you mean by surface tension? Surface tension is nothing but it is a force per unit length which is perpendicular to the surface. Now that is due to the different attractive forces in the molecule. So अगर आपने एक liquid ले लिया, example liquid, say for example water in a beaker, right? Or water in a beaker and exposed to it is placed in the air. So there is a some force in the water, okay, in the bulk of water molecule you will have some force known as a attractive force. Now from the bulk of water the molecule are attracted equally from all direction. अगर water का molecule bulk में है, bulk of liquid मतलब bulk of liquid में, so say for example you can see over here beaker है आपके पास में, some water molecules are on a surface, some water molecules are on a bulk. So for example यहाँ पे एक bulk molecule है, so it will be attracted by other molecules, it will be attracted by other molecules from all direction equally, that force. Okay, now the molecule which are present on the surface, that is attracted by unequally, it is attracted by downward, the molecules which are present in the bulk, but because here you have air, so this molecule is only attracted from downward, and that downward pull is nothing but the surface tension, right? There is a surface tension, it is a force per unit length of surface which is perpendicular to the surface length. Okay, that is known as a surface tension, right? And whatever force is there, same force in between interface known as the interfacial tension. Now electrolyte, okay, electrolyte addition of slight lower amount of electrolyte, addition of electrolyte increases the surface tension, whereas surfactant, whereas a surface active agent, whereas a detergent, whereas a surfactants, they decreases the surface tension. तो आपको याद रखना है कि electrolyte in a less concentration they will increase the surface tension, whereas a surfactant will decrease the surface tension of liquid. So water has a surface tension of 74. Okay, water has a surface tension of 74.75. Now temperature also increases the surface tension. Temperature also increases the surface tension. Temperature increases the surface tension of liquid due to increased kinetic energy, which decreases the attractive process. टेम्परेचर आपने दे दिया लिक्विड को तो उसके मॉलिक्यूल का काइनेटिक एनर्जी बढ़ जाता है. बिकॉज ऑफ दैट इट इंक्रीजेस द सरफेस टेंशन and decreases the attractive forces. Now, unit of surface tension in a CGS unit, CGS system is a dyne centimeters inverse. CGS में surface tension का यूनिट होता है dyne centimeter inverse and SI यूनिट में होता है न्यूटन मीटर इनवर्स. न्यूटन मीटर इनवर्स, न्यूटन मीटर इनवर्स. One dyne centimeter inverse is equal to meter Newton meter inverse. Okay, so you can see over this phenomenon. This is a water molecule which is present in the bulk of liquid. Bulk में है ये liquid की bulk में. So this molecule is attracted in every direction equally. So attractive forces over here in this molecule is equal from all direction. Right? So this molecule is present at the bulk. So this molecule is also present in the bulk of liquid. Now consider this molecule. This molecule is present at the surface of the liquid surface, right? Now in this molecule, in this case so this molecule is attracted by this molecule and in opposite direction this molecule, but these forces are cancelled equally. But here you have air, so in this direction this molecule is not attracted. From the molecules present in the bulk, they will have force, they will be attracted. So this downward pull, this net downward pull is known as a surface tension force. Okay, now if you force directed at the interior of the medium, that is a surface tension. Because of this inward pull, liquid has a surface tension. Liquid has a surface tension. Now if you place a liquid drop in a air, अगर आपने वाटर का ड्रॉप एयर में प्लेस कर दिया, अगर आपने एक वाटर का ड्रॉप डाल दिया एयर में, मतलब खुले में हवा में छोड़ दिया वाटर का एक ड्रॉप, so what will happen? So drop will try to assume a shape which will have a minimum surface area. अगर वाटर का ड्रॉपलेट, अगर आपने वाटर का ड्रॉप अगर छोड़ दिया आपने एक, जैसे मान लीजिए ड्रॉपर से वाटर का एक ड्रॉप डाल दिया ऊपर से नीचे, so एयर में जब आएगा वो ड्रॉप क्यों बनता है? Why that water is getting a spherical shape? That is the reason, that is surface tension. Okay, so liquid in a air will try to acquire minimum surface area. Okay? Minimum, it will try to expose a minimum surface area. It will try to acquire a minimum surface area because of the surface tension. That's why it is a spherical in shape, right? So methods for determination of surface tension and interfacial tension. So method क्या है इसमें? So if you want to go in the detail, you can read from book, but we will also take from same chapter from book. Doesn't matter, 2 दिन लगते हैं, 3 दिन लगते हैं. So capillary rise method is there, then tensiometer method is there, then bubble pressure method is there, DMER method is there, and drop weight method is there, drop count method is there. So there are different methods. Okay, so we are going to see these methods in the detail. Don't worry, in the upcoming session you should know what are the methods for the measurement of surface tension. Surface tension, interfacial tension के लिए कितने methods है? मेन ये methods है. So capillary rise method, tensiometer method, bubble pressure method, drop weight, drop count method, drop volume method is there, then DMER method is there. यहाँ पे drop weight method, drop count method है, drop volume method भी है. So out of this we'll see in a short 3 methods. First is a capillary rise method. So if you place a thin capillary in a liquid, अगर आप लिक्विड का बीकर है, आपके पास वाटर का बीकर है, उसमें अगर कैपिलरी इंसर्ट करेंगे तो जो लिक्विड का सरफेस है बीकर में और कैपिलरी का पॉइंट ऑफ अटैचमेंट है, तो उससे भी आगे कैपिलरी में वाटर ऊपर चढ़ता है. सो देयर इज अ राइज इन द वाटर लेवल इन द कैपिलरी बियॉन्ड द सरफेस ऑफ वाटर. नाउ दिस इज बिकॉज ऑफ द सरफेस टेंशन. Now that rise is dependent on the internal diameter of capillary, the viscosity of water and all that. So there is only expression used to calculate the surface tension by capillary rise method. So if you want to go, you can go in the reading form. So it is used to measure the surface tension only. Capillary rise method is only used to measure the surface tension. You cannot measure interfacial tension by using capillary rise method, right? So and it gives accurate results as long as contact angle of liquid with the capillary is zero. जब तो contact angle zero होता है capillary और liquid के बीच में, capillary rise method will give you accurate result. अगर ज़्यादा contact angle होगा तो results will be not accurate. Second method is the DMER ring method. इसके ऊपर क्वेश्चन आ चुका है. So क्वेश्चन 2-3 बार आ चुका है as like this. So platinum iridium ring is used in the following method for measurement of surface tension. So DMER ring method, so also known as the DMER tensiometer. Also known as the DMER tensiometer. It is used for measuring of surface tension as well as interfacial tension. ये मेथड दोनों के लिए होता है. It is used for measurement of surface tension as well as interfacial tension. Okay? Surface tension and interfacial tension is proportional to the force which is required to detach the platinum iridium ring immersed at a surface or interface. इसमें एक platinum iridium ring होता है and उसमें वो surface के ऊपर रखना है आपको और है ना डिप करके उसको उठाना है. और फोर्स रिक्वायर्ड टू डिटैच है ना सरफेस में ऊपर जब आप वो रिंग सरफेस के ऊपर आता है तो वाटर मॉलिक्यूल जो है उसमें सरफेस टेंशन होता है. सो ऑब्वियसली इट विल रेज द पुल अप ऑफ दैट इरिडियम रिंग. दैट इज द फोर्स रिक्वायर्ड to detach the platinum iridium ring immersed at a surface or interface is nothing but the will give you surface tension. A small quantity of liquid is sufficient to measure the surface tension by this method. Contact angle of liquid must be zero. Contact angle of liquid with the ring must be zero. In this case, third method is nothing but the drop count method. Drop count method. In this case, use of stalagmometer, stalagmometer or drop pipette. It is used for measuring both surface tension as well as interfacial tension. Wilhelm plate method. So it is used for measurement of both surface as well as interfacial tension, and this method is same as that of the DMER ring method, but just difference is that in case of DMER ring method, now replace that ring with the thin plate made from a platinum. Here is a plate of platinum. Now surface tension maintains liquid surface area to a minimum. Because of the surface tension, liquid is able to maintain the surface area to its minimum. अगर आपने वाटर एक ड्रॉप डाल दिया एयर में, वाटर इमीडिएटली आप एज्यूम करेगा वाटर विल एज्यूम a shape like this. Why? Because of the surface tension. Okay? Because of the surface tension, it will try to maintain minimum surface area. Now surface free energy is nothing but the work required to increase the surface area of liquid by 1 square centimeter. Surface free energy क्या होता है? It is nothing but the work required to increase the surface area of liquid by 1 square centimeter. And remember, surface free energy is nothing but the surface tension. It is equal to the surface tension. Now surface tension of few commonly used liquids at a 20 degrees. You can see water का surface tension होता है. वाटर का सरफेस टेंशन कितना होता है? दे कैन आस्क यू 72.75. इंटरफेशियल टेंशन नहीं है वाटर का, ठीक है, बिकॉज वाटर सिंगल फेज है. कार्बन टेट्राक्लोराइड हैज सरफेस टेंशन ऑफ 26.8, इंटरफेशियल टेंशन 45. इंटरफेशियल मतलब क्या? इफ यू पोर कार्बन टेट्राक्लोराइड इन वाटर, कार्बन टेट्राक्लोराइड एंड वाटर दे आर इमिसिबल. नाउ इन दिस केस इंटरफेशियल टेंशन इज सिर्फ कार्बन टेट्राक्लोराइड में इंटरफेस नहीं होगा. इंटरफेस के लिए आपको दो लिक्विड चाहिए, टू इमिसिबल लिक्विड चाहिए, राइट? सो वाटर, कार्बन टेट्राक्लोराइड इन वाटर, देन ओनली यू विल हैव इंटरफेशियल टेंशन. सो क्लोरोफॉर्म का सरफेस टेंशन होता है 27.1. इंटरफेशियल टेंशन क्लोरोफॉर्म विद वाटर इज 32.8, है ना. डाइन पर सेंटीमीटर और मीटर न्यूटन मीटर. Mercury has the highest surface tension. Remember, mercury has a 470 highest surface tension, and mercury water 375 interfacial tension. Benzene has a surface tension of 28.88, and benzene plus water interfacial tension is 30. इथेनॉल सरफेस टेंशन कितना होता है 22.4. N octanol has a surface tension of 27.50. In water it has an interface of 8.5. Olive oil का surface tension होता है 35.8. Olive oil in water interfacial tension is 22.9, like this. In hexane 18.4 surface tension. Interfacial tension with respect to water is 51.1. Oleic acid surface tension 32.5. Interfacial tension with respect to water 15.6. Ethyl ether 17. Water dissolved में interfacial tension 10.7. Isopropyl alcohol has a 21.7. So this is a interfacial tension and surface tension of few commonly used liquids. Now this data is new to you, and remember classification methods for surface tension and interfacial tension of liquid and solids. ठीक है, ये क्लासिफिकेशन के ऊपर क्वेश्चन आ सकता है आपको. Which method is a static method, which is a dynamic method, how you can measure the surface tension of solid. So remember, measuring of surface tension of liquids. Now, there are two methods. First is a static method. Static method, there is no movement. Dynamic method means there is a movement. So liquid surface tension of liquid or interfacial tension of liquid can be measured by static method. So surface tension can be measured by Wilhelm plate method. Interfacial tension can be measured by spinning drop method. These are the static method. Wilhelm plate method for surface tension and spinning drop method for interfacial tension. Both are the static method, right? Now dynamic method in this, okay, both surface and interfacial tension कैसे measure करेंगे. So in the static method surface tension will Wilhelm plate method, interfacial tension spinning drop method, both surface tension as well as interfacial tension, DMER method and pendant drop method. Right? Dynamic में आता है the dynamic methods for measurement of liquid surface tension and interfacial tension. Dynamic method for measurement of liquid surface tension only. Capillary rise method, bubble pressure method, drop weight method. Measurement of interfacial tension by dynamic method of liquid, drop volume method. Measurement of both surface as well as interfacial tension, drop number method. Now in case of solid, there is only surface tension, okay. So it can be measured by sessile drop method, dynamic Wilhelm plate method, okay, powder contact angle method. These are the methods. ये classification आपको ये बहुत सारे बुक में नहीं दिया है. It is given in the physical pharmaceutics 1 by निराली प्रकाशन. उसमें डॉक्टर अशोक आचार्य सर का जो बुक है उसमें. So this is new to you. So they may ask you question like this: what is the static method for measurement of surface tension only? Question already आ चुका है. Which method measures surface tension only? So whatever is important we are taking. So we'll see that chapter thoroughly from the book. Now surfactants. Surfactants means are what? Surfactants means they are the molecule containing both lipophilic as well as hydrophilic portion. सर्फेक्टेंट में क्या होता है, लिपोफिलिक पोर्शन भी होता है एंड हाइड्रोफिलिक पोर्शन भी होता है. दे आर नोन एज सरफेस एक्टिव एजेंट. दे आर एक्टिव एट सरफेस. दे विल रिड्यूस द सरफेस टेंशन. surface active agents or surfactants, they will reduce the surface tension. Now they are classified into three types. Anionic surfactants. First one is the anionic surfactant. Anionic मतलब क्या, negatively charged. Anion होता है ना, anion negatively charged होता है. So anionic surfactants, they will have a negative charge. So example is a carboxylate. They will have very common ions, negative anions. So they will have commonly anions like carboxylate, as in case of soap surfactant. Then sulfonate, sulfate ions, okay. Alkyl benzyl sulfonate, so they are known as detergents. Then soaps of fatty acids. Lauryl sulfate known as a foaming agent. Okay. So this sodium lauryl sulfate is a foaming agent or detergent, mostly used in the soaps and toothpaste and all that. Dialkyl sulfosuccinate, ये इसको वेटिंग एजेंट बोलते हैं. लिग्नोसल्फोनेट, डिस्परेंस टू डिस्पर्स द सॉलिड पार्टिकल्स इन द लिक्विड. देन नेक्स्ट होता है आपका केटोनिक सर्फेक्टेंट. सो केटोनिक सर्फेक्टेंट्स यू विल हैव पॉजिटिव चार्ज ऑन दैट. एनानिक केटोनिक सर्फेक्टेंट में लॉन्ग चेन केटोनिक अमाइंस होते हैं. केटोनिक अमाइन सॉल्ट हो सकते हैं and mostly they are used as an antimicrobial preservative. Possibly with betaines and amphoteric surfactants, carboxylate phosphate as anion and quaternary ammonium group as a cation. इसमें दो होता है. HLB values of some surfactant we already seen yesterday in this, but again see sodium lauryl sulfate. What is the HLB of sodium lauryl sulfate? बहुत बार क्वेश्चन आया, दो चार बार आ चुके हैं GPAT. So HLB of sodium lauryl sulfate is a 40. Normally HLB values are in a range of 1 to 20. Normally HLB values are in a range of 1 to 20, but some compound have HLB value more than 20, and example is nothing but the sodium lauryl sulfate 40. Okay, इसके ऊपर बहुत बार क्वेश्चन आ चुका है. HLB is nothing but the hydrophilic lipophilic balance, and because in the molecules, in the surfactant molecule you have both hydrophilic group as well as lipophilic group. So to characterize them, there should be some arbitrary scale which was developed by Griffith in 1940, known as the HLB scale. So यहाँ पे सोडियम लॉरेल सल्फेट का होता है 40, सोडियम ओलिएट का होता है 20, पोटेशियम ओलिएट का होता है पोटेशियम ओलिएट का होता है 20, सोडियम ओलिएट का होता है 18. सोडियम लॉरेल सल्फेट 40, सोडियम potassium oleate 20, sodium oleate 18. Oleic acid being a lipid, it is having HLB1. Oleic acid का HLB1 होता है. Sorbitan tristearate 2.1, glycerol monostearate 3.8, gelatin का HLB पूछा है already, it is 9.8. What is the HLB value of gelatin? GPAT 2023. इसके ऊपर भी 23 में क्वेश्चन आया, 23 में इसके ऊपर भी आया. very important part है. It is very important, that's why I'm taking again. Now twin 20, twin 80, they will have 16.7 and 15 HLB respectively. HLB is nothing but the arbitrary scale, एक scale होता है indicating the extent of lipophilic and hydrophilic balance. कि उसमें lipophilic group कितने हैं, hydrophilic group कितने हैं, based upon that molecule either will be lipid soluble or water soluble. तो उनको characterize करने के लिए this system was proposed by Griffin in 1949. known as HLB scale. Higher the HLB value of surfactant, HLB value अगर surfactant का ज़्यादा है, more will be the hydrophilicity. ना जो HLB value ज़्यादा है किसी surfactant का, उसका मतलब वो hydrophilic ज़्यादा है. So more will be the hydrophilicity. Lower will be the HLB value of surfactant. Higher will be the lipophilicity. है ना? अगर तो कोई surfactant का value कम है, उसका lipophilicity ज़्यादा है. कोई सर्फेक्टेंट का वैल्यू ज्यादा है, उसका हाइड्रोफिलिसिटी ज्यादा है. जैसे फॉर एग्जांपल ओलिक एसिड हैज अ HLB वैल्यू ऑफ 1, तो ओलिक एसिड का लिपिड है, लिपिड ऑयल है, सो इट इज द हाईएस्ट लिपिड है ना, इट हैज अ लिपोफिलिसिटी. जैसे सोडियम लॉरेल सल्फेट, उसका HLB होता है 40, सो उसका मतलब ये होता है कि इट इज अ हाइड्रोफिलिक. आर यू गेटिंग और नॉट, समझ रहा है? और सर्फेक्टेंट स्पैन एक नाम होता है स्पैन 20, स्पैन 40. सो इट इज नथिंग बट द सॉर्बिटन ईस्टर और सॉर्बिटन ईस्टर, उसको स्पैन बोलते हैं. दे आर द लिपोफिलिक बिकॉज दे हैव HLB इन अ रेंज ऑफ 1.8 to 8.6. राइट. ट्विंस जो होते हैं, ट्विंस दे आर नथिंग बट द polyoxyethylene derivative of span sorbitan. So they are the hydrophilic in nature, they have HLB in a range of 9.6 to 16.6. यहाँ पे एग्जाम्पल भी दिया है कि है ना कि सर्फेक्टेंट का अगर HLB कम है तो उसका मीनिंग होता है कि वो लिपोफिलिक है. अगर सर्फेक्टेंट का HLB ज़्यादा है तो उसका मीनिंग होता है कि वो हाइड्रोफिलिक है. ये ऑलरेडी अपन ने देखा है. तो HLB स्केल डेवलप्ड बाय ग्रिफिन. सो ऑन दिस स्केल द मॉलिक्यूल्स आर given a numbers. ठीक है. So scale is ranging from 1 to 20. So the surfactants which have HLB from 1 to 10, so they are known as lipophilic surfactants. 1 से लेके 10 तक वैल्यू वाले लिपोफिलिक होते हैं एंड 10 से लेके 20 तक हाइड्रोफिलिक होते हैं. इससे ज़्यादा भी हो सकता है HLB. Based upon the use. So lot of times they already asked question on this. So what is the HLB value for anti-foaming agent? So it is a 1 to 3. उसके बाद में OW mL per 3 to 8. Then wetting and spreading agent. So that is a 7 to 9. OW emulsifier. HLB range is a 18 to 16. 8 to 16. Then detergents, they are having range 13 to 16 HLB value of detergents. Then solubilizer will have HLB of 16 to 20. इसके सबके ऊपर एक एक बार क्वेश्चन उसमें important है, right? Now methods for calculation of HLB. So there are different methods to calculate the HLB. First method is known as the Griffin's method, and that is applicable for non-ionic surfactant. तो non-ionic surfactant जो होते हैं, say sodium chloride sulfate is a non-ionic surfactant. So for application, for calculation of HLB value of SLS, you can apply this formula. So Griffin's method for non-ionic surfactants. HLB is equal to method formula याद रखना. HLB is equal to 20 into mH divided by m. 20 into mH divided by m. mH क्या है? महाराष्ट्र नहीं है. Where mH is nothing but the molecular mass of hydrophilic portion, and m is nothing but the molecular mass of whole molecule. So it will give result on a scale 0 to 20. So this scale is also based upon this formula. And HLP value of 0 correspond to completely lipophilic molecule. ऐसा क्वेश्चन पूछा है. HLP value 0 means what? It is a lipophilic molecule. HLP value 20 correspond to complete hydrophilic molecule, right? So Griffith's method. Second method होता है आपका for non-ionic surfactant. Again, non-ionic surfactant having हाइड्रोफिलिक पोर्शन पॉलीऑक्सीथिलीन. अगर हाइड्रोफिलिक पोर्शन में पॉलीऑक्सीथिलीन है नॉन आयनिक सरफेक्टेंट का, so in that case HLB is equal to E divided by pi. E is nothing but the percentage weight by ethylene oxide. ये क्या है? इथिलीन ऑक्साइड का परसेंटेज. इसका फॉर्मूला क्या है? HLB is equal to E divided by. फॉर्मूले भी पूछा है एक दो बार. Now third is nothing but the for surfactant containing polyhydric alcohol fatty acid ester, such as a twin span glyceryl monostearate, sorbitan monostearate. तो इनका HLB कैसे कैलकुलेट करें? So HLB for twin span glyceryl monostearate, sorbitan monostearate, oleate, monostearate, monolaurate, monolaurate. So HLB can be calculated by this formula: 20 into 1 minus S divided by A. 20 into 1 minus S divided by A. What is A? What is S? So S is nothing but the saponification number of that surfactant, and A is nothing but the acid number of fatty acid. So polyhydric alcohol containing ester of fatty acid, for surfactant containing ester of fatty acid with alcohol, and ester of fatty acid with alcohol अगर है, so in that case HLB is equal to 20 minus 1 minus 20 into 1 minus S divided by A. This is nothing but the saponification number. A is nothing but the acid number of fatty acid. For material such as a beeswax, lanolin, ये जो surfactant होते हैं, so they will not have good, okay, they will not, it is not to obtain, it is not easy to obtain the saponification number. So in this case HLB value is calculated as E plus P divided by pi. E क्या है? What is E? E is nothing but the percentage weight of ethylene oxide, and P is nothing but the percentage of polyhydric alcohol groups. So in this case you can calculate the HLB of lanolin beeswax in this way. तो याद रखना है ग्रिफिथ मेथड का फॉर्मूला होता है आपका HLB is equal to 20 into m H divided by m. For non-ionic surfactant having hydrophilic portion as a polyoxyethylene, HLB is equal to E divided by 5. है ना? For twin span, है ना, twin span glyceryl monostearate, sorbitan monostearate, monolaurate, monolaurate, HLB is equal to 20 into 1 minus S divided by A. इसका है saponification number of ester, ये क्या है? acid value. So those surfactant for which saponification number is not possible, so for that HLB is equal to E plus 5, E plus P divided by 5. E क्या है? Percentage of ethylene oxide, and P क्या है? Polyhydric alcohol, right? So again there is one more method you can see over here. Method based upon the percentage, or method based upon the component of group of surfactant. Surfactant में क्या है? Surfactant में दो ग्रुप होता है, हाइड्रोफिलिक ग्रुप एंड लिपोफिलिक ग्रुप. Method based upon the component of group of surfactant. Assign a group number. एक group number assign किया जाता है उनको depending upon the number group कौन सा है, और वो group number का list भी दिया है. Okay, there is also list given in the one book, है ना, निराली प्रकाशन का एक बुक है अशोक आचार्य सर का. उन्होंने वहाँ पे बुक ये ग्रुप के नंबर भी दिए, मतलब सल्फेट ग्रुप को कितना नंबर असाइन करेंगे, CO ग्रुप को कितना असाइन करेंगे, वो भी दिया है. सो इफ यू वांट टू, ना, अगर वो मैंने अभी लिया नहीं, उसमें कंटेंट बहुत ज़्यादा हो जाएगा, बट वो ऐड करूँगा मैं methyl based upon the compound. So it is nothing but the summation HLB is equal to nothing. HLB is equal to summation of hydrophilic group number plus summation of lipophilic group number plus 7. HLB is equal to summation of hydrophilic group number minus lipophilic group number plus 7. H minus E, H minus L plus 7. Hydrophilic group number minus lipophilic group number plus 7. That is a method based upon the groups of surfactant molecule, right? Okay. So if you add a surfactant, अगर आपके पास liquid है, water है, if you add a surfactant in this, मान लीजिए आपके पास ऑयल है और वाटर है, यहाँ पे ऑयल है ना, ऑयल वाटर. If you add a surfactant in this, initially surfactant will, few molecule of surfactant will get at the interface. कुछ molecule जो है surfactant के interface पे जाएंगे and remaining molecule will be in a bulk of liquid. If you increase the concentration of surfactant, अगर बहुत और concentration आपने add किया, so what will happen? Initially surfactant molecules will be individual entity. At a low concentration, surfactant molecule will be a individual entity. Okay, and it is present as individual. Okay, so it has a both hydrophilic group, that is known as hydrophilic head, and hydrophobic group known as a tail. Now initially surfactant molecule will be a separate entity, but if you increase the concentration, so there is increase in the association, there is a aggregation of these surfactant molecule to form a spherical or different shapes known as a micelle. Now the concentration of surfactant at which there is a formation of micelle takes place, known as a CMC, known as a critical micelle concentration, known as a CMC. क्या होता है CMC? The concentration of surfactant at which there is a formation of micelle, known as CMC. इसके ऊपर बहुत बार 2-4 बार क्वेश्चन आ चुका है. Critical micellar concentration. Critical micellar concentration is the concentration of surfactant at which there is a formation of micelle in the solution. What is meant by Kraft point? इसके ऊपर भी क्वेश्चन आ चुका है. Kraft point is also known as a Kraft temperature or also known as a critical micellar temperature. Kraft point or Kraft temperature or critical micellar, it is nothing but the minimum temperature at which surfactant will form micelle. The concentration of surfactant at which there is formation of micelle known as a CMC, critical micellar concentration, and the temperature at a CMC is known as a Kraft point or Kraft temperature. Same thing. Okay? So it is a minimum temperature at which surfactant will form a micelle. Below the Kraft point, surfactant cannot form micelle. Question इसके ऊपर 2-3 बार आ चुका है. The Kraft temperature is the point at which there is a phase change. ना Kraft temperature जो होता है उस टाइम पे phase change होता है ना. Kraft temperature के ऊपर क्या होगा? माइसिली फॉर्मेशन हो गई, माइसिली फॉर्म हो गया, मतलब वो एग्रीगेशन होगा, है ना. फेज चेंज होगा ना, पहले नहीं था, अभी एग्रीगेशन होगा, फेज चेंज. सो Kraft temperature is the point of phase change below which the surfactant will remain in a crystalline form, means soluble form, and even it will remain in a aqueous solution. Okay, but at the Kraft temperature, surfactant solubility of surfactant will decrease. Now surfactant in such a crystalline state will only solubilize and form a micelle if another surfactant will assist. In this case सर्फेक्टेंट माइसिली का फॉर्म करेगा अगर दूसरा सर्फेक्टेंट मॉलिक्यूल उनको असिस्ट करता है, उसके नियर बाय आता है ना, अट्रैक्ट हो जाता है. If another surfactant assists in overcoming the forces that keep crystallized, or if the temperature increases, thus causing entropy to have a stronger force and encouraging the crystalline structure to break. Surfactants usually are composed of a hydrocarbon chain and polar head, है ना. तो polar head होता है इसमें, that is a polar head, और बाकी लिपोफिलिक पार्ट जो होता है that is known as a polar head. क्या होता है? हाइड्रोफिलिक पार्ट. जो टेल होता है लिपोफिलिक टेल. सो इंक्रीज इन द लेंथ ऑफ हाइड्रोकार्बन, ये जो लेंथ है हाइड्रोफोबिक ग्रुप जो होता है हाइड्रोफोबिक ग्रुप, सो इंक्रीज इन दिस हाइड्रोफोबिक ग्रुप और इंक्रीज इन दिस लेंथ हाइड्रोकार्बन चेन लेंथ will increase in the chain length of hydrocarbon will increase the Kraft temperature. जितना हाइड्रोकार्बन का चेन बढ़ जाएगा Kraft temperature बढ़ जाएगा. इसके ऊपर भी क्वेश्चन आ चुका है. Because of the increase in the van der Waals process. Important है, चीजें आपको याद ही रखना है, कल ऑलरेडी अपने देखा है. Now HLP values of surfactant with example, ये भी पार्ट ऐड किया है मैंने नया. So एग्जाम्पल के साथ में आपको HLP वैल्यू देखना है. ठीक है. So first, anti-foaming agent. Are you able to see the screen properly? Yes. Okay. HLB, ठीक है, HLB value. तो एंटी फॉर्मिंग एजेंट HLB वैल्यू रेंजेस फ्रॉम 1 to 3. आपको ये तो मालूम है, लेकिन एग्जांपल क्या है एंटी फॉर्मिंग एजेंट? सो ऑब्वियसली ओलिक एसिड एंटी फॉर्मिंग एजेंट 1 HLB, सोर्बिटन ट्राइस्टेरेट 2 HLB, ग्लिसरील मोनोस्टेरेट 3 HLB. सो 1 2 3 ओलिक एसिड, सोर्बिटन ट्राइस्टेरेट, ग्लिसरील मोनोस्टेरेट. तो ये क्या है? स्टेरिक एसिड. मोनोस्टेरेट मतलब एक स्टेरिक एसिड, ग्लिसरील मोनोस्टेरेट. ग्लिसरीन का मॉलिक्यूल प्लस एक जो OH ग्रुप है उसके स्ट्रीफाई किया है विद स्टेरिक एसिड, तो दैट्स व्हाई मोनोस्टेरेट. अगर दो जगह पे स्ट्रीफाई होता है तो ग्लिसरील डाइस्टेरेट, तीनों पे होता है तो ग्लिसरील ट्राइस्टेरेट. So emulsifying agent OW emulsifiers, okay, will have HLB in a range of at least 3 to 13. Okay. So you can see sorbitan monooliate, उसको अपन बोलते हैं स्पैन. क्वेश्चन आ चुका है. स्पैन 80 मीन्स व्हाट? स्पैन 80 मीन्स व्हाट? sorbitan monooliate. So HLB इसका होता है 4. ग्लिसरील मोनोस्टेरेट अगेन 5. डाइथिलीन ग्लाइकॉल मोनोलाउरेट 6. इमल्सिफाइंग एजेंट एज वेल एज वेटिंग एजेंट एज वेल एज स्प्रेडिंग एजेंट. तो इमल्सिफाइंग एजेंट इसमें भी आता है वो वही ये मतलब these are emulsifying agent OW emulsifiers as well as wetting agent as well as spreading agent. तो 7 का एग्जांपल नहीं उतना नहीं. सोर्बिटन मोनोलाउरेट दैट इज अ स्पैन 20. सोर्बिटन मोनोलाउरेट दैट इज स्पैन 20. HLB होता है 8. पॉलीइथिलीन लाउरिल ईथर नोन एज अ ब्रिज 30, है ना, उसका HLB 9, है ना. बाद में मिथाइल सेलुलोज नोन एज अ मिथोसेल 15 CPS उसका विस्कोसिटी होता है 10 HLB. तो ये इमल्सिफाइंग एजेंट OW इमल्सिफायर, WO इमल्सिफायर नो. मिथाइल सेलुलोज है 10. पॉलीइथिलीन मोनोस्टेरेट नोन एज अ मिर्च 55 11. ट्राइथोलामाइन ओलिएट 12, है ना. बाद में इमल्सिफाइंग एजेंट OW इमल्सिफायर प्लस डिटर्जेंट पॉलीइथिलीन ग्लाइकॉल 400 मोनोलाउरेट 13 होता है उसका 13. बाद में पॉलीइथिलीन सॉल्बिटन मोनोओलिएट ट्विन 80 का 15 होता है. देन इमल्सिफाइंग एजेंट OW इमल्सिफायर प्लस सोल्युबलाइजिंग एजेंट प्लस डिटर्जेंट पॉलीइथिलीन सॉल्बिटन मोनोलाउरेट 18 उसका ट्विन 18 बोलते हैं उनको. HLB होता है 16. पॉलीइथिलीन लाउरिल ईथर ब्रिज 35 17. सोडियम ओलिएट 18, है ना. पोटेशियम ओलिएट 20. लास्ट में ऑल इन वन सरफेक्टेंट होता है, उसको अपन बोलते हैं सोडियम लाउरिल सल्फेट. इज नंबर 40. HLB इज 40. तो आपको क्वेश्चन ऐसे आएगा, व्हाट इज HLB वैल्यू ऑफ लाउरिक एसिड, व्हाट इज HLB वैल्यू ऑफ ओलिक एसिड. ओलिक एसिड का 1 होता है. HLB वैल्यू ऑफ स्पैन 80 4. व्हाट इज स्पैन 80? सोर्बिटन मोनोओलिएट. व्हाट इज स्पैन 20? सोर्बिटन मोनोलाउरेट. HLB होता है उसका 8. व्हाट इज द, है ना, व्हाट इज द ब्रिज 30? पॉलीइथिलीन लाउरिल ईथर नोन एज अ ब्रिज 30 सरफेक्टेंट 8 और 9 होता है उसका. मिर्च 45 क्या आता है? पॉलीइथिलीन मोनोस्टेरेट लाइक दैट, है ना. सो ट्विन 80 क्या होता है? पॉलीइथिलीन सल्फेटन मोनोओलिएट. इसके ऊपर क्वेश्चन आ चुका है जीपी. सो दिस चार्ट अगेन वेरी इंपॉर्टेंट. नेक्स्ट, एब्सॉर्प्शन आइसोथर्म. एब्सॉर्प्शन आइसोथर्म. Adsorption on a solid surface. Adsorption on a solid surface is known as adsorption isotherm. Adsorption on a solid surface known as adsorption isotherms. That is given to form either a monolayer or multilayer known as a adsorption isotherm. So what is it? It's a graph between amount of adsorbate, that is X, amount of adsorbate adsorb on a adsorbent. इसमें दो होता है, adsorbate ना, जो एडसॉर्ब हो रहा है और जिसके ऊपर एडसॉर्ब हो रहा है वो उसको बोलते हैं आप एडसॉर्ब एट अ प्रेशर एट अ कांस्टेंट टेम्परेचर. डिफरेंट एडसॉर्प्शन आइसोथर्म हैव बीन लाइक दिस. फ्रेंडलिच आइसोथर्म, लैंगम्यूर एंड बेट थ्योरी. डिफरेंट आइसोथर्म होते हैं. फ्रेंडलिच एंड देन लैंगम्यूर आइसोथर्म, एडसॉर्प्शन आइसोथर्म, एंड देन बेट थ्योरी. फर्स्ट टाइम इट वाज ऑब्जर्व बाय दिस फ्रेंडलिच एंड लैंगम्यूर. Right? So formation of monolayer जैसे solid है, for example sodium. Solid के ऊपर adsorption कैसे होगा? लेयर, है ना, उसका adsorption isotherm से. Friendly's adsorption isotherm. So Friendly's isotherm correctly establishes the relationship between adsorption with the pressure at a lower values. The lower pressure K and at a pressure lower value, this phenomenon is known as Brand-Leach adsorption isotope. So adsorption of gas on a solid surface. Adsorption of a gas on a solid surface at a lower pressure known as a Brand-Leach adsorption isotope. It is given by equation y is equal to x divided by m kp raised to 1 divided by n. X y का है x is nothing but the mass of gas adsorbed on the mass of adsorbate at a pressure. K and n are the constant values. Those depends on the adsorbent and gas of particular temperature. दूसरा होता है Langmuir adsorption isotherm. Langmuir equation is depicted in relationship between number of active site. तो एक्टिव साइट मतलब सॉलिड के ऊपर कितने एक्टिव साइट है उसके ऊपर डिपेंड करता है कितना गैस एडसॉर्ब. So number of active sites on the surface undergoing the adsorption and pressure. Langmuir isotherm क्वेश्चन आपको ऐसे आता है कि which adsorption isotherm will depict the adsorption of gas at a lower pressure. So Friedrich adsorption isotherm or which adsorption isotherm okay will give you relationship between number of active site of the surface undergoing adsorption and pressure to Langmuir adsorption isotherm. Langmuir adsorption isotherm. It is given by y is equal to ym bp divided by 1 plus bp. What is y and this? So where number of active site is denoted by theta covered by gas molecule. P represents the pressure, K represents the equilibrium constant and surface and gas phase. Basic limitation of both these adsorption isotherm, Brand-Leach and Langmuir, is that they are valid for low pressure only. These isotherm only explain the monolayer adsorption. Monolayer मतलब गैस का मोनोलेयर ही बना है ना, एक मॉलिक्यूल का ही लेयर है उसके ऊपर दूसरा मॉलिक्यूल नहीं है. That is nothing but the bilayer. So these adsorption isotherm they explain the adsorption of gas on a solid monolayer absorption at low pressure है ना. डेरिवेशन इसका बुक में दिया है. इफ यू वांट टू रीड मोर you can read from book. Okay, you can read from book. At a lower pressure kp is equal to is very small and it is negligible. That factor k 1 plus kp is a denominator can almost be ignored. So Langmuir equation will reduce to 0 is equal to kp. At a high pressure kp is so high, so large. Factor 1 plus kp is in a denominator is nearly equal to kp. So Langmuir isotherm उसका reduce किया जाता है बेट theory. What is बेट theory? बेट is nothing but the Brunauer-Emmett-Taylor. Brunauer-Emmett-Taylor will also explain the adsorption isotherm and its type. The multi-layer formation was explained by बेट theory. इसके ऊपर क्वेश्चन आ चुका है. So multi-layer adsorption isotherm was explained by बेट theory. Brunauer-Emmett-Taylor. ठीक है, तो उसका इक्वेशन है like this. P divided by y into P0 minus P is equal to 1 by ymb plus bp minus ymb P into P divided by P0. P क्या है? प्रेशर है ना at a absolute in mm per g. Y is the mass of paper. P0 is the partial pressure of monolayer. Ym is nothing but the mass of paper adsorbed per unit mass of adsorbate. P is the constant. Different types of adsorption isotherm क्वेश्चन आता है इसके ऊपर भी. So you can see different type of adsorption isotherm. There are at least 5 adsorption isotherm. Type 1 is nothing but the you can see this one is known as type 1 adsorption isotherm. So it is a Langmuir adsorption isotherm. Above graph depict the monolayer adsorption. Type 1 adsorption isotherm is nothing but the monolayer adsorption. It can be easily explained by using Langmuir adsorption isotherm. Example of type 1 adsorption are nothing but the adsorption of nitrogen or hydrogen on the charcoal at a 180 degree minus 180 degrees. Adsorption of nitrogen and hydrogen on charcoal is nothing but the type 1 adsorption isotherm. Example कभी कभी आता है example के ऊपर क्वेश्चन. Second आपका आता है type 2. Type 2 adsorption isotherm shows large deviation from Langmuir adsorption isotherm. The intermediate flat region in isotherm corresponding to formation of monolayer. अब देखो यहाँ पे सेकंड एडसॉर्प्शन है, so it will deviate from this laminar system and this flat region is nothing but the formation of monomer. एग्जाम्पल क्या है इसके, एडसॉर्प्शन ऑफ नाइट्रोजन एट -195 ऑन आयरन कैटलिस्ट और एडसॉर्प्शन ऑफ नाइट्रोजन ऑन सिलिका जेल एट -195 डिग्रीज. एग्जाम्पल याद रखो. टाइप 3 एडसॉर्प्शन आइसोटोम. टाइप 3 एडसॉर्प्शन आइसोटोम also shows deviation from Langmuir model. This आइसोटोम explain the formation of multilayer. मल्टीलेयर के लिए ये ऐसा क्वेश्चन आता है, which adsorption आइसोटोम explain the multilayer formation. So type 3 adsorption आइसोटोम. If you plot a pressure versus number of molecules adsorption, number of molecule of gas adsorption, the graph is known as the adsorption isotherm, right? So type 3, this where there is no flattish portion in the curve which indicate the that monolayer formation is missing. यहाँ पे कोई फ्लैट पोर्शन नहीं है, यहाँ पे फर्स्ट में यहाँ पे फ्लैट पोर्शन है, इसमें भी मोनोलेयर, इसमें नहीं है. एडसॉर्प्शन आइसोटोम टाइप 4, इसके एग्जांपल देख लो टाइप 3 के. सो एग्जांपल ऑफ टाइप 3 एडसॉर्प्शन आइसोटोम, ब्रोमीन at 79 degrees Celsius on a silica gel or iodine at 79 on a silica, bromine or iodine adsorption on a silica gel. Type 4 adsorption isotome. Type 4 क्या है? At a lower pressure, region of graph is quite similar to type second. Type 4 का जो है ना, type 4 का it is quite similar to graph second. देखो यहाँ ट्रिप उल्टा है. This explains the formation of monolayer followed by multilayer. This explains the formation of monolayer followed by. Type 5 represents the adsorption of gas on porous solid and shows the capillary condensation. Example is include the absorption of benzene on silica gel. Type है ना, type 5 adsorption isotome explain the similar to type 4 है ना. Example of type 5 adsorption isotome is a water adsorption water vapor at 100 degrees Celsius on a charcoal. Type 4 and 5 shows phenomenon of capillary condensation of gas. Spreading coefficient. Spreading coefficient. Spreading मतलब क्या है? And spreading मतलब it is applicable in the ointment and creams while application. Okay. So spreading coefficient means, so it should be easily spreadable. It should be easily spreadable. A drop of oleic acid placed on the surface of water will spread as a thin film, which is a spontaneous process, and surface free energy of system is reduced. So by reducing the surface free energy, you can increase the spreading coefficient. Spreading coefficient has application in the absorption of creams, lotions, solubilization of emulsion. Spreading coefficient is nothing but it is a function of adhesive forces plus cohesive forces. Spreading coefficient क्या होता है? Function of adhesive forces and cohesive forces working between the. Explain examples of spreading coefficient. Some spreading coefficient is given over here. So spreading coefficient of liquid on a water. Spreading coefficient of liquid on water, you can see over here. So benzene has a spreading coefficient of 8.10. Liquid petroleum has a -13.41. Ether 44, 45.44. Oleic acid 24.21. Ethanol 50 and octane -0.2. So this is the spreading coefficient. तो स्प्रेडिंग कोएफिशिएंट है, उसमें और पढ़ना है तो स्प्रेडिंग एंगल भी पढ़ सकते हो आप.